gas chain. It is seamless by design. For myself, I am from software engineering background. I am sorry if I am going to dig today. Okay, so clearly the main feature of Aleo is privacy. However, I want to point out that there is like overlap between privacy and decentralization. When you talk about decentralization, you can think it's like a censorship resistant system which is unstoppable. In other words, what I want to say is like if you can achieve privacy, you can achieve decentralization too. And privacy is like pre-driver to the progressive decentralization. To be more specific, there are three pillars of the privacy. First one is unlinkability. Secondly is untraceability, and finally is undetectability. To be more clear, let me introduce all this in this slide. In the first pillar, I will talk about the unlinkability first. Bitcoin use like the key pair cryptography. Simply speaking, anyone can just generate the private key using mathematics formula or just like a mathematics like this of chance, and then they can derive the public key, or simply speaking, it's just like an address that we use to send money from one to like another. The point I want to make is like the third party cannot link or find a relationship between these bands, or like I would say like there is no connection between these identity at all. So that is like a kind of privacy. It is not like a traditional system like you use email. Sometimes like a third party or like a user maybe just look back at the centralized server and then they just know that there is some connection between this identity, right? So in the first pillar, like both Bitcoin and Ethereum use like key pair cryptography so that they can solve unlinkability. However, only key pair cryptography doesn't solve like untestability. What is untestability? It's like it is very low possibilities that third party can know the final destination of the transaction, or maybe the final recipients of the transaction. For instance, if I send some tokens from one address to another address, finally, because of the transaction that are because of those public features are public, this means that third party can still know who conduct the first transaction, or who are the sender, or like who are the recipient, like so that it is still testable. So that there is someone who solve this problem. For the next pillar, like when the EVM comes, EVM is like a blockchain that developer can like totally complete program. It's like you can just write any business logic in that same development. So that's what ContributionDAO does is like they try to like missing privacy protocol. What it does is like it allows users to generate proofs that some depositor has deposited some money into that smart contract, and this means that using that proof could be sent to the verifier, which is smart contract, and proof that they had already deposited that money without reviewing who are the depositor. Actually, when going into the code, it not that simple because it's just like there is many tricky way to just like try to optimize the gas and like something like that. So that there are so many limitations. So that's only possible. So that's only popular and working implementation here. There is only missing protocol, so that there are no any other complex application case. It's like there can't be any working or popular world thing application right now because it will cost too much gas. Next, however, is like Bitcoin and Ethereum because they are public blockchain, like it is designed for lighting the depth that are public. They are not designed for the privacy, right? So that what if we have like a new world that optimized for the privacy, so that there will be more use case like maybe autonomous voting and maybe autonomous work, like using ticket snap or mini computer paste, maybe some diplomatic box game or some kind like that. So that's the ultimate goal of the privacy, which is the last thing I want to talk about. The last pillar of the privacy is like the undetectability. The undetectability mean there is no way to know that transactions to place in the first place. It's like so that is like a complete privacy. And what Aleo want to solve is like they want to move from like undetectability to the undetectability. So that what Aleo offer is like they offer zero gas emissions because behind the scenes they will move computations off chain. So that let's say when they try to encrypt data into proof, they can do it if off chain. Then the proof will be sent to be modified on chain. So that part can be caused by zero gas, and the second benefit is like the unlimited application on time because the computation will be computed off chain, so that Aleo can just sponsor that computation cost. But how it works behind the scene? In the old way, like Bitcoin and Zcash, we also privacy money. It use UTXO model, which stands for like unspent transaction model. Actually, it is designed for the money payment or or like token transfer or stuff like that. The UTXO model consists of like input and output, where input is just reference to the previous output, and output is just a new value created by user. However, this model is not appropriate at all for programming ability. Like so that Ethereum said that we should use a new model, which is account model. Account model, in this account model, transaction consists of sender, receiver, value, and data field. So, simply speaking, it's just like one address has like a balance, or it's just that. And with this, it allows for programmability. So to enable privacy, Aleo just use the combination of the both worlds. So they just use like the combination of the account model and the UTXO model. So they can achieve zero gas limits and unlimited action time. Okay, so what Aleo provides for the developer ecosystem, there are 5 components here. The first one is Aleo SDK. It is just simply software development kit designed for the developer who use JavaScript so that they can design web-based applications. And then we have Leo. Leo is like a programming language that can allow people to zero knowledge focus design applications. What it does is it usually helps developers to abstract many complexity. It's developers don't have to write the constants or the circuits by themselves. They don't have to know about the zero knowledge glossary. It's they don't have to know the polynomial stuff or some kind of that. They have to know about the monoid or like some crazy complex zero knowledge stuff. They can just boost the logic right away. So what the Aleo compiler does, it will compile the high level request to the Aleo instruction, and then now you can call the instruction, and now it's just the resource management for all of those components. Okay, so what it will do is we will try to reduce from the ground up. You can start. I know it may be complex at first. I think this slide will help you to understand more. If you compare to Ethereum, you can compare the SnapS is the Validator, and SnapS is the prover, but if it was in Ethereum, it's just the block producer, and VO is the solidity. Yeah, I think I can compare it that way in very simple words. Right. So, for example, if you write the Leo programs, I want to prove that the sum of the two numbers a plus b equals c without revealing the real value of a and b. What you do is we all compile down to the Aleo of course, Aleo instruction of course, and for the complexity by ways they can just the n class in all of the inputs and then they will generate proof, and then it just send it to verify on chain. Like so the point here is like it will execute on chain, and then it will verify on chain. Okay, so with Leo, like crypto developer can finally with like many decentralized finance applications. The objects are endless. There are use cases that are quite limited these days, but with this technology, you can add the privacy feature into your application. Like for example, you can develop token swap that without failing about the funding of the MEV, which is quite a big problem in the DeFi space right now, because every transaction because on the blockchain like Ethereum are public, so that there may be like MEV attackers try to know the transaction in advance and just try to make like a sandwich attack. But with privacy feature, you can just prevent that. And maybe modify Oracle, just like loosening of chain, it may be allow more security maybe, and there is many more use cases like maybe like simulated gaming or like autonomous world. If you hear this word, it may be like the dark forest that develop on the Ethereum the Ethereum system. However, like the gas is like very high, so that it is not practical in level. So that with this, maybe we have more scalable game, and maybe like privacy preserving machine learning, or there may be like also zero knowledge web service. Okay, so how can you get involved with Aleo or want to do some contribution to the Aleo ecosystem? There are two types of grants. First one is innovation grant. You can just write very simple or like Leo smart contracts, and then you just deploy on the testnet, and you can just attach the grants. Also there are also moving grants. Actually the ecosystem is quite immature now, so that many libraries and companies, there are a lot of stuff to do in the programming language. If you want to contribute, you can just apply for the grants. And the last grant for the level business case, you can just apply and hopefully your proposal should pass. Okay. So if you have some question or want to know more about information, you can just want to attend more of the Aleo events. You can just simply scan QR code. Okay, so this is the resource if you want to dig deep more about Aleo. Then you can go to Aleo box, Twitter, Discord, or the official website, or maybe the playground, GitHub. I know that there are a lot of I want to going on today. However, I have to try to speak in like very simple language. I am so sorry if I miss anything out, or like my stuff that I have been saying is not technically correct. Okay, I think that's wrap up. Thank you.
Alright guys, thank you Rati for the presentation. The pizza is here and here, and I think you guys know what to do now. Yeah, I'll catch you on the floor. Thanks.
Good, my job.